Google just confirmed that scammers are stealing bank account credentials from Android phones at a scale that is costing people nearly $1 billion every single year. Not hypothetically, not eventually. Right now, today, on phones that look completely normal and show no signs that anything is wrong. And the reason most people never see it coming is because the attack does not come from obvious malware or suspicious-looking apps. It comes from settings and permissions that are already active on your phone, that you probably enabled at some point without thinking about it, and that are giving malicious apps and scammers direct access to your one-time passwords, your banking credentials, and your account authentication codes the moment they arrive. Today, I'm going to show you exactly what. Which settings are creating these vulnerabilities, exactly what attackers are doing with them, and exactly what you need to change right now before your account becomes the next one that gets drained. Start with the scale of the problem because the numbers from Google's own security team are staggering. Eugene Lederman, Director of Android Security and Privacy at Google, confirmed in the company's 2026 SecHero ITI announcements that phone scammers spoofing bank caller IDs are driving an estimated $980 million in annual losses worldwide. That figure comes from Europol data, and it represents only the losses attributable to one specific type of attack. The broader picture of Android banking credential theft is significantly larger. Google has been forced to introduce an entirely new category of security features in 2026, specifically because the existing protections were not stopping the attacks at the rate they were occurring. When Google builds an emergency response into its operating system, the threat driving that response is real, and it is happening at scale. The first and most critical vulnerability to understand is SMS permission combined with the way one-time passwords work on your phone. When your bank sends you a verification code by text message, the cation on your phone that holds SMS, read permission, can access that inbox, any application. Not just your messaging app, every single app you have ever granted SMS permission to. Google confirmed in its 2026 security update announcements that scammers are routinely using malicious apps that have been granted SMS permission to intercept one-time passwords from text messages and forward them to attackers before the account holder even sees the message arrive. The attack happens in milliseconds. The code appears, gets captured by the app, gets forwarded to the attacker, and the attacker uses it to complete authentication on your account before you have had time to read the notification. You may see the text message arrive and assume it was triggered by your own action. By then, the damage is done. Google's response to this specific threat is a new feature rolling out in Android 17 that automatically hides one-time passwords from most apps for 3 hours after they arrive. The feature has already rolled out in Android 17 Beta 2, according to Android Out. Hority reporting. But this protection only works on devices running the updated software. If your phone is running an older version of Android, that protection does not exist yet. And SMS intercepting apps on your device can still read every OTP code your bank sends you in real time. The second major vulnerability is accessibility services permission. And it is the one that security researchers consistently identify as the most dangerous category of permission that exists on Android. Accessibility Services was designed to help users with disabilities interact with their devices by allowing applications to read screen content. Observe user interactions, and in some implementations, act on the device on behalf of the user. Every one of those capabilities is exactly what a banking Trojan needs to steal your credentials. An app with Accessibility Services permission can watch everything you type into your banking application. It can read your account numbers and balances as they display on screen. It can observe the moment you authenticate successfully and capture the session that follows. It can place fake login screens over the top of your real banking app and capture the credentials you enter into them believing you are logging into your bank. Google's Live 3, a detection system which the company confirmed is being expanded in 2026, now specifically flags suspicious SMS forwarding and accessibility overlay abuse in real time. But the protection only triggers after the behavior is detected. The permission itself remaining active on an app that has not yet exhibited suspicious behavior, creates a window of vulnerability that exists for every app currently holding Accessibility Services access on your device. Go to your phone settings right now and find Accessibility. Look for the section that shows which apps have been granted Accessibility Services access. This list should be short. It should contain only apps you deliberately configured for accessibility, or poses, such as screen readers, voice control tools, or switch access systems. If you see any application in that list that is not something you consciously set up for a specific accessibility need, that permission needs to be revoked immediately. A game, a utility, a file manager, a flashlight, a productivity tool, none of these have any legitimate reason to hold accessibility. services permission, and their presence in that list is a direct security vulnerability on your device right now. The third vulnerability is the overlay permission, which Android labels as display over other apps or appear on top in your settings. This permission allows an application to draw content on top of other applications while they are running. The legitimate use cases include floating chat bubbles and persistent notification systems. The attack use case is placing a PIX, a perfect replica of your banking app's login screen directly over the real banking app the moment it launches. You open your bank app, the malicious overlay detects the launch event, and before the real login screen finishes loading, the fake one appears on top of it. You enter your credentials into what appears to be your bank's INT RFIs. Those credentials go directly to the attacker. The real app never receives them. You may see an error message and try again, entering your credentials a second time into the same fake screen, giving the attacker a confirmed working set of login details. Google's 2026 security roadmap confirmed that dynamic signal monitoring, a new feature watching application to system interactions in real time, will specifically target overlay abuse. But again, the protection is reactive. The permission being active on your device before the abuse is detected is the gap that attackers exploit. Check your overlay permissions now. Go to Settings, find Apps, look for Special App Access, and find Display over other apps. Review every application with this permission. Enabled. Be specific and honest about whether each app has a genuine reason to draw content over other applications. If you cannot immediately explain why an app needs this capability, remove the permission. The fourth vulnerability is something that most people have never thought about because it seems completely harmless. The 2G network setting on your device. Google confirmed in its 2026 security announcements that Android 17 is introducing carrier configurable options to disable 2G connectivity by default in areas where older network infrastructure is no longer maintained. The reason this matters for password and credential security is that 2G networks have well-documented security weaknesses that allow attackers with relatively accessible equipment to intercept communications, execute SIM swapping attacks more easily, and conduct IMSI catcher attacks that capture data from nearby devices. If your phone is connecting to 2G networks in situations where 4G or 5G is available, that connection is significantly less secure than it should be. On Android devices running Android 12 or later, you can find a setting to disable 2G connectivity in the network and internet section of your settings menu. Enabling this setting removes a category of network-level attack that is actively used against Android users. The fifth issue is rooting and what it does to your banking security in ways that most people who root their devices do not fully understand. According to security analysis published in 2026, rooting in Android Devi, C breaks verified boot, which is the chain of trust that confirms your operating system has not been tampered with. It also causes most banking applications to fail their integrity checks through the Play Integrity API, which is exactly why your banking app may refuse to open on a rooted device. And for Samsung users specifically, rooting permanently activates a security fuse that can never be reset, eliminating Knox protection forever. These are not theoretical risks. They are direct consequences of bypassing the security architecture that protects your financial applications. Google's Identity Check feature, which was expanded in 2026 to cover all apps and services using Android's biometric prompt, including third-party banking apps and Google Password Manager, adds a layer of protection that specifically targets the scenario where a thief observes your PIN before stealing your phone. Identity Check requires biometric authentication, your face or fingerprint, to access sensitive settings or applications when you're outside your trusted locations. A thief who knows your PIN cannot change your passwords or access your banking apps if Identity Check is active and your biometric data is not available to them. This feature is available on Android 15 and later devices and should be enabled in your security settings if it is not already active. The advanced protection mode available in Android 16 and later is worth enabling for anyone who wants comprehensive coverage without configuring individual GS manually. It restricts app installations to the Play Store, enables more aggressive malware scanning, and blocks unauthorized downloads from outside Google's verified distribution system. For most users, this represents the most significant single security improvement available with one setting change. Here's the complete checklist of what to do right now. Open your accessibility settings and revoke accessibility services permission from every app that is not a deliberate assistive technology you configured yourself. Open your special app, access settings, and revoke display over other apps permission from every app that does not have a clear and specific reason to draw content over other applications. Check which apps hold SMS read permission and remove it from anything that does not have an obvious and necessary reason to access your text messages. If your Android version supports it, disable 2G connectivity in your network settings Enable Identity Check in your security settings if you are running Android 15 or later. Enable Advanced Protection Mode if you are running Android 16 or later. Keep your Android version updated because the OTP hiding feature, live threat detection improvements, and verified financial calls system rolling out in Android 17 specifically address the attack methods that are costing people nearly $1 billion a year. Google confirmed that scammers causing $980 million in annual losses are using methods that exploit exactly the permissions and settings described in this video. The protections Google is building into Android 17 exist because those attacks are happening. Right now on phones that have not been configured to resist them, check your settings today. The few minutes it takes to audit your permissions is the difference between your banking credentials staying private and ending up in the hands of someone who will use them before you realize they are gone.